Okay, so what I see here is a lot of really good stuff. I like a lot of what I see here, okay? You wrote down all your givens. That's great. You thought about it. You drew a picture. Wow, you must have had an awesome Physics 20 teacher. Okay, so this looks great. Even this is an awesome setup, okay? This is a little beyond what we did in Physics 20, but it's not too far off, right? In fact, you can see kind of the roots of what we did. We did d equals VIT plus 1/2 AT squared. Well, now we're just saying if you're not starting at some initial position, just add whatever y position you're starting at, right? If you're starting from 1 meter off the ground, then do it the way we would have done in Physics 20, but then add 1 meter. We're just kind of cooking that in there. Okay, now this note, absolutely true. Okay, and it's not affecting anything you're doing here. I do just want to mention something about it. This and the way you've drawn it, absolutely true. And maybe you even knew this and I'm saying it for no reason, but I just wanted to make sure you're careful. This is true. It's accelerating for the same amount downward as it did upward. So it will end up with the same velocity it started with, except now down. Just be careful for one like this. That is going to happen once it reaches the height it left from, right? But then it keeps accelerating down. So it will actually hit the ground with a greater velocity than it went up with. But you're absolutely right with the way you've drawn it here. Here, v equals negative VIY, or I should say Vy equals negative VIY, okay? But that has nothing to do with what you asked me about. You asked me about manipulating this thing, okay? So don't forget, what are we doing when we're manipulating? We are trying to get something all alone by itself, right? Now, the issue usually is it's not by itself. It's having things done to it, right? It is having operations done to it. And that's the key. If you remember that manipulating is just trying to undo whatever is being done to it, it makes it a bit easier. There's always kind of a consistent logic. So, you know, in math, when we're solving stuff, we say bed mass, right? And we do that forwards. Okay, when we're manipulating, we do the reverse order of operations. Okay, Sam Deb. So first we have to kind of think big picture, subtractions and additions. Then we can move closer and look at any multiplications and divisions that are happening. Then we can look at any exponents. Then we can look at any brackets. Okay, and the reason we do the reverse order of operations when manipulating is because remember, we're trying to undo the stuff, right? So for example, if you tell me that we want t, right? Well, t is having a whole bunch done to it. It's being multiplied by VIY. We need to undo that, right? So we're going to do the opposite. But before we can do that, we first need to follow our reverse order of operations. Yi is being added to it, okay? So you're not off in what you're doing here. For example, multiplying by 2 is the opposite of 1/2. You're right, okay? It's just that we weren't ready to do that yet, okay? And this one is actually going to be a bit different. It's something we didn't quite do in Physics 20. I brought it up. But here, let me just show you from the beginning. Okay, so absolutely great start. Love this. Looks great. So you've got YF equals YI plus our initial velocity in the y-axis times time. Okay, that was all you. That looks good to me. Now, if we were going to manipulate this for time, your first move, okay, because of that reverse order of operations, that not bed mass, but Sam Deb, and again, it's backwards because we're undoing the operations that are happening to the thing we want alone, right? We're not doing them, we're undoing them. That's why we do it backwards. So when I look at this, right, I see a t, okay, and then there's a yi being added to it. So my first instinct would be, let's do the opposite of adding y initial to these things, okay? So we just subtract yi from both sides, and then we just say, okay, yf minus yi, right? Just rewrite what we got now. Okay, and then normally what we would do is we would keep moving on and say, okay, well, I dealt with the subtractions and additions that were kind of happening there, but let's pretend this t wasn't there because that's going to change how we do this one, right? But you would just continue on and say, okay, what's happening to this t? It's being multiplied by a and 1/2. So what's the opposite of that? Well, divide by 1/2 or multiply by 2, right? And divide by a. And then that would be gone, right? That would be over here now. We're divide the whole side by 1/2 a, okay? And then we could deal with the exponents. Now we've dealt with that, okay? Now, I'm brushing over, you kind of heard me say it there, let's pretend this one doesn't exist because you're probably noticing something. You're probably looking at that right now and saying, hang on, there's 2 expressions with t in it. How am I ever supposed to get t equals something if I've got 2 annoying t's here, right? If I subtract VIYT, well, now I've just got a t on both sides. I'm not any closer to getting t by itself, right? If I divide everything by t, that doesn't do it. That gets rid of this t. but this t is still here, right? So now I've divided this side by t, and I've just made this t squared into a t. It's getting messier, it's getting worse. Whenever you see this, whenever you see that you have two different t's with two different powers, okay? Because if they were just t, we could just combine these like terms, which is one thing I did want to comment on here in your solution as well. Totally get what you were thinking here, right? T plus t squared, which is 2t squared, okay? That doesn't actually quite work, right? T and t squared are, I think of them like, well, apples and oranges. They're kind of different things, right? They can't add like that. And so whenever you're wondering, okay, because I get it, I all the time on math, I'm doing it and I say, can I actually do this? I can't remember if this works out. Make up numbers and try it. See if it works. So I don't know, let's do, if t is 2 plus 2 squared equal to 2 times 2 squared? So 2 plus 2 squared is 2 plus 4. 2 times 2 squared, which would be our 2t squared, right? So we're just saying, is this equal? Well, 2 times 2 squared is 2 times 4 is 8. Uh-oh, okay, so it looks like that doesn't work, right? So this is not actually okay, but I get why you want to do it because you were thinking, I've got 2t. So you can't combine those terms, right? But one's t squared. There's no way to ever get this in a nice expression where it's just t equals blah, blah, okay? Unless we use the quadratic formula. So you might recall from physics 20, I told you all that if you ever need to use this equation, this d equals vit plus 1/2 at squared, if you ever need to use it to solve t, vi will have to be 0. And I said that's not because the quadratic equation is super hard, it's just because you learn it in Math 20, and some of you might not have taken Math 20 yet because you're only in Physics 20 right now. Maybe you have Math next semester, right? However, now that you're in your higher level physics courses, you have taken Math 20, obviously, and so you do know the quadratic formula, and so that's why your physics courses are now saying you can solve for t with the quadratic formula because you've done Math 20. So when this happens, that's okay, right? It totally happens to me all the time. You start manipulating, you go, hang on, I'm never going to get this by itself. I'm never going to get just t. That's okay. This is your clue. You've got a t and a t squared. Say, okay, neither of these things are 0, so I can't cancel one out. So that's okay. I'm going to have to use the quadratic formula, which you might remember is of the form ax squared plus bx plus c. Sorry, this isn't the quadratic formula, but I need to get my equation into this form to use the quadratic formula just because it's set up that way, okay? So the quadratic formula is set up to work when you have it written this way because we're going to use, when we rewrite our equation to look like this, then we can just plug the a, the b, and the c into our quadratic formula. So I'll just show you what I mean, right? If it's like this, then x equals negative b. So whatever, when we write it like that, whatever is where that b is, plus or minus the square root of b squared minus 4ac all over 2 times a, okay? So we need to write it like this just because the quadratic formula is set up so that when you write it in this form, you can just pull a out and say, okay, that's a, pull b out and say, okay, that's b, and then pull c out and say, okay, that's c. Depending on your teacher, I don't know, you might have to memorize this or you might not, okay? I don't know. But anyway, back to my point. So now what do we need to do? We need to make this thing here look like this thing here so we can put in our B, our A, our C, and our A, obviously, okay? So that means we need to get everything on one side and just set it equal to 0. So we're kind of going to undo the first thing we did, right? My only point there was to show you just kind of the idea behind manipulating and the reverse order of operations. But then we realized we're never going to get t by itself. Let's put everything on one side and set it equal to 0, and then we can use the quadratic. So I'm going to start back where you started, right? Okay, and now for quadratic, everything must be on one side and the other side of the equal sign be 0, so just subtract yf. So then just reordering everything, we have 1/2 ayt squared plus viyt plus yi, right? And then we just subtracted yf. Just all I did was basically just reorder this to go from the highest power of t to the lowest, because you'll notice that's how the quadratic is. Okay, and that's now equal to 0. And so notice this now looks like the quadratic, right? Now my a, okay, is 1/2 acceleration. That's A, right? My B is now VI in the y-axis. My C, well, C just means a number, right? And YI, hey, that's just a number that we have. YF, that's just a number we have. That's just a constant. We can put those both in and just get a number. In fact, I believe it's 2. Yes, 2. Okay. So we're going to go ahead now and we're going to put in our numbers, okay, so that we can figure out what's B, what's AC, and what's A, right? Literally, we just have to say, you already told me up there in your givens what A is, what VIY is, and what YI and what YF is. So we're just going to plug that in and then stick it in our quadratic, and we'll go from there. So A, I'm not going to put my units in, even though I really should, but just in the interest of time, I'm not going to. Okay, plus YI was 2 minus YF was 0, and you're absolutely right about both of those things. Okay, so 2 minus 0 is obviously 2. Just going to simplify this a bit. 1/2 times negative 9.81, well, that is negative 4.905. Don't round, okay, but that's not rounded. That is exactly what your calculator will say. Okay, now notice, there we go. For our quadratic, we now have A is negative 4.905, B is 13, C is 2. So what do? We go here, okay? Our x is t. This depends on time. That's what we're trying to find, was time, right? We've modeled this motion of this object as a function of time in this way, okay? So just like any other equation, we're allowed to solve it with the quadratic if that's what it calls for. So now we're going to go up here, okay? And now we're going to say t equals negative b plus or minus the square root of b squared, 13, minus 4a is negative 4.905. Uh-oh, this is going to get crowded. Don't drop that negative, okay? Do not drop that negative. You'll get the wrong answer. Times c is 2. Okay, now that's all over 2a, which is 2 times negative 4.905. Now you're probably saying, okay, plus minus, that means we have 2 possible t's, and you're absolutely right, except we will only actually have one physically possible t. So what I mean by that is, in math class, yes, you do the quadratic, you get 2 possible values of x that will work for that equation, that would solve that equation, okay? In physics, though, the numbers have to actually make sense. They have to be real, right? So sure, this equation models it, but don't forget it's really the equation of a parabola, right? And one of them doesn't make any sense because it has a negative time, okay? So this is the parabola that models the person throwing it. There's their hand, they threw it up, and it fell, okay? Now, since this in math class would just be a parabola, right, the math is going to say, okay, well, there's 2 places where it hits the ground. It hits the ground here in the future, but it also hits the ground here in the past, which of course doesn't make any sense. It hits the ground here at some negative time, okay? So when we do this, we'll always get one positive t and we'll get one negative t. The negative t is non-physical, we say. It doesn't make sense, okay? There's no such thing as a negative time. So we just go ahead and work them both out, right? We do the 13 plus all this divided by this, and then we do the negative 13 minus all this divided by this. So you'll get, okay, when you plug that all in your calculator, and don't be a hero, okay? Don't try to do it all at once. This is something that is begging for mistakes to be made as you plug it in, okay? But if you carefully do it and write down what you're doing, I got that when we add, so when we do the negative 13 plus all this divided by this stuff, you get t equals negative 0.14582 seconds. Now that doesn't make any sense. How could the time be negative, right? So the math is telling us that one, right? The math doesn't know. You have to be a bit of a physicist and think about it and say, okay, well, that's not the correct solution because that's non-physical. That doesn't make any sense. So it must be our other one. Let's see what we get. Negative 13 minus this time. Okay, and if you punch all that into your calculator very carefully, and you can kind of even tell that this one's going to be positive because you've got a negative minus something that has to be positive divided by a negative, right? So we have a negative over a negative. This is going to work out positive. This is looking good. I got T equals 2.7962 seconds, which, if we do to the appropriate number of sig digs, should be 2.80 seconds. Okay, so the reason it threw you off is because we never actually did these manipulations in Physics 20. You did them in Math 20, and in Physics 20, we worked with the equation. Now it's being put together, okay? Quadratics and your kinematics formulas. So let's just review what we did really quick, okay? We started with our equation. All we were going to do was the reverse order of operations. We were going to do opposite operations to get t by itself. But on our very first step, we noticed, hang on, t and a t squared, we're never going to get just t equals blah, 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 right? Because that t and that t squared are never going to cancel with each other to give us something nice. Hey, we're going to have to use the quadratic formula here, which, by the way, the quadratic formula always does work. It's just sometimes more work. So if you can avoid using it, you might want to, okay? But it does always work, even on easier ones, even when VI is 0, okay? Just a heads up for that. But anyways, we said, okay, quadratic formula, that's of the form ax squared plus bx plus c equals 0. And this you may or may not have to memorize, okay? But it is the quadratic formula. So you write your equation like this. You say what's where a is, what's where b is, what's where c is. Notice it's always ordered from the highest power of x to the lowest. So from x squared to x to the power of 1 to no x, or x to the power of 0 technically. So we did that to our guy here. We did t squared, our t, and then our t to the 0, or our constant term, a, b, and c. What are they? Stick them in the quadratic, okay? Quadratic is always built in with two possible answers, the +1 and the -1. So we did the +1, got a negative. That is the non-physical answer here, where instead of going forward in time and falling, it somehow went backward in time, which of course is not what happened. So we said, okay, must be the other one, and then we got that one. Okay, so that's basically what there is to that. Hope that's helpful.